Hello ninth class. Today we are going to start a chapter number 13, that is a Pythagoras Theorem. Its proof and simple applications with a converse. So see, in this triangles there are three sides. Pythagoras Theorem is related to a triangle, that is a right angle triangle, in which one angle is of 90 degree, right? Here you see there is a triangle whose side is A, B and C. See, C is a longest side and B is a perpendicular, A is a base and C is a hypotenuse. So what is the Pythagoras theorem? That is A square means square of base plus square of perpendicular is equals to square of hypotenuse. So what is the statement? In a right angle triangle, the square of hypotenuse is equals to the sum of the square of the base and perpendicular, or you can say that sum of the square on the remaining two sides. See students, in your exercise 13a, the first question is a ladder 13 meter long. See, ladder always in the shape of like this, okay? So ladder which is in a 13 meter long rest against a vertical wall, okay? This one is a ladder and this one is a wall. It is standing like this. And if the foot of the ladder, this, and there is a foot of ladder which is a 5 meter, see in a diagram, from the foot of the wall. Find the distance on the other end of a ladder from the ground. So we have to find here perpendicular, which is a AC. See in a question, Pythagoras states that in a right angle triangle, the square of hypotenuse is equal to sum of the remaining two sides. So what is here? AB square is equals to AC square plus BC square. Now what is AB? AB is a 13. So that is a 13 square is equals to BC, that is 5 meter, that is 5 square, plus we have to find a CA. We write it as CA square. So CA square is equals to 13 square minus 5 square. 13 square is 169 and square of 5 is 25. So what is the answer? 169 minus 25, we get a 144, and square root of 144 is 12 meter. Therefore distance of other end of a ladder from a ground is 12 meter, right? See question, next question. Two poles of height 11 meter and 6 meter. See, let us suppose there is a one pillar, one pole and another one is a there. This one is a 6 meter and this one is a 11 meter. We know that 11 meter is a longer one and 6 one is a smaller. So stand on the plain ground. So if they are a stand on a plain ground, that ground are plain. If the distance between their feet of the poles, we have to tie the pole in a plain ground. So when we have the distance between that ground, that pole, one pole to another pole, that is a 12 meter. Find the distance between their toe. So first of all I meet BD and there is a base is 12 meter and its one pole is of 6 meter and second one pole is of a 11 meter. Now height of first pole, that is AB, which is a 6 meter, and height of a second pole, which is a CD, that is a 11 meter, and distance between the feet of pole is a 12 meter. Now we have to find a distance between the two poles. So how we have to find a distance between the two poles? See, let us draw a line. First of all we draw a line BE. Okay, I meet B with E, which is a parallel to a AC, right? Which is a parallel to a AC, and BE is perpendicular upon a DC. So since AC is also perpendicular to DC as a pole to a vertical ground, so BE is equals to AC, BC is equals to AC is equals to 12 meter. See, AC and BE, they both are a parallel line, so they both are a 12 meter. And similarly, if AB is 6 centimeter and EC is also be a 6 centimeter. Now see, DE is equals to BC minus EF, which is equal to 5 meter. Now we have to find a BD, distance between the two poles. So firstly we take a triangle BDE. So here we have a DE 5 meter, BE is 12 meter, we have to find a BD. So what is a BD? That is a BD square is equals to BE square plus DE square. So what is a BE? BE is a 12 square plus DE is a 5 square. So when we have to solve it, 12 square of 12 is 144 and square of 5 is 25. So what we get? We get 169, which is a BD. And the square root of 169 is 13. So what is the answer? Answer of BD is 13. Hence the distance from between the top of the pole is equals to 30 meter. Right students? Now come on to next question. That is AD is drawn perpendicular to a BC of an equilateral triangle ABC. See, there is a triangle ABC, which is an equilateral triangle, and we know that if the triangle is an equilateral, then its all sides are equal. So given that BC is equal to 10 centimeter, let us suppose that there is a triangle that is a B and C. Now if BC is 10 centimeter, it means AB is also 10 centimeter, and BC and AC, these three sides are equals to 10 centimeter, and we know that any line drawn perpendicular to opposite side in equilateral triangle bisect each other. So BD is equals to 1/2 multiplied by BC, which is BD is a 5 centimeter. Again we have applied the Pythagoras theorem, that is AB square is equals to AD square minus BD square. Now AD square, that is AB is a 10 square, which is equals to AD square minus 5 square. We have to solve it and we get the answer, that is AD, which is equals to 5/3. Now we put a value because he wants to get he want answer correct to one decimal place. So then we have to put the value of √3, which is 1.732 up to, so on after multiplying we get 8.66025405. So we want up to one decimal, so answer is 8.6. Okay. Now see next question. If the sides of a triangles are in a ratio 1 to √2 and 1, show that it is a right angle triangle. First of all, we know that if the term is given in a ratio form, then we firstly put a x with that number. Okay. So here let us suppose that in a given triangle, say A is equals to x, B is equals to √2x and C is equals to x. Now we have to apply Pythagoras again, that is A square minus C square is equals to B square. Now here you have to take a hypotenuse, that is √2, which is a bigger one, because always hypotenuse is a bigger side. So you people take a bigger side as a hypotenuse, and you can take any side as a perpendicular and a base. After solving it you get the answer. Now see in 13th B, same concept we people are using, that is again a Pythagoras, just related to some questions related to this. In a rectangle ABCD, prove that AC square plus BD square is equals to AB square plus BC square plus CD square plus DA square. So see students, in a solutions we have a quadrilateral ABCD. Right. So now first of all tell me what the Pythagoras state. Pythagoras states that in a right angle triangle, square of hypotenuse is equals to square of remaining of two sides. Now ABCD is a rectangle, right, in which ABCD, these four are right angles, right. We consider first of all ACD. Okay, first of all on a ACD we apply the Pythagoras, that is AC square ACD. Now see AC is a bigger one side, so AC square is equals to DA plus CD, right. Similarly we take another triangles, that is a BDC. Here same, BD square is equals to BC square plus CD square. Now we firstly add to these both terms, which one given from a first triangle and which one from a second triangle. We add it and we get an answer. Okay. Now come on the next question. In a triangle ABC, AB is equals to AC and BD is perpendicular to AC. Prove that BD square minus CD square is equals to 2 times of CD multiply AD. Now see students, you people see that there is a triangle, that is a ABC, right? Now ABC is a triangle and we put a BD as a perpendicular upon a AC, right? Again it is a right angle triangle. Now what we do? We are just applying the that is a Pythagoras theorem, right? Now see in A, firstly I will take a triangle ADB, right? ADB, clearly you can see that AB is a hypotenuse, right? And AD and BD are remaining two sides, right? Now AB square is equals to AD square plus BD square. Okay. Now after that you want AD in that side. So AD square is equals to AB square minus BD square, and we can also see AC is a baseline and D is a midpoint. So can we write it as AC is equals to AD plus DC? Okay. I write it as, now squaring on both sides, open the square, put a values and you get a answer. Okay. Now students, with this your 13th chapter is complete. Try to solve this homework on your notebooks so that be practice. If there is any doubt, then please give me in a comment section. Thank you and have a nice day.